Okay, welcome to today's lesson. In this video, we'll be looking at centripetal force and some calculation questions under centripetal force. So, what is centripetal force? Centripetal force is the force that keeps an object moving in a circular path. Centri means circular, right? So, the force that keeps an object moving in a circular path is what is known as centripetal force. Right? So there is a force that keeps a tire rolling in a car. That's a centripetal force that keeps it moving in that circular path. So again, centripetal force is a force that keeps an object moving in a circular path, right? All the planets are revolving around the sun. There is a centripetal force that keeps them moving in that circular path. So one thing that you must know is that centripetal force is always directed towards the center of the circle. The force is always directed towards the center of the circle. So the formula of centripetal force is centripetal force, which is Fc is equal to mv squared all over r, where your F is equal to your centripetal force, your m in this formula is the mass, your v squared is the velocity, while your arrow is the radius, right? So this formula is very important. Centripetal force F C is equal to mv squared all over what? All over arrow. So to take us further, uh, centripetal force, like I said, is the force that keeps an object moving in a circular path, right? Moving in a circular path. So you can see this object. Let's say this is an object moving in this circular path, round, moving in this circular path. The force that keeps it moving round is known as the centripetal force. And you have a lot of circular motions in nature. The tire moving round the axle is an example of a circular motion. So the force that keeps it moving round is the centripetal force. So there are some important things that you should know about centripetal force. One of which is the direction is always changing. The direction of any body or of any object undergoing centripetal force or undergoing a circular motion is always changing. The direction of any object or any body undergoing a circular motion is always changing. So this is depicted there. As the object is moving around, right, there is a tendency for it to move towards this direction. The direction is always changing. But because the force is there, the centripetal force is there, it will pull it again. In that sense, it will pull it again so that it can maintain its circular motion. As it turns like this, there is a tendency for it to move towards this direction. But the force will pull it again towards this direction. As it moves towards this direction, there is a tendency for it to move towards this direction. But the centripetal force doesn't give it that chance. It pulls it again. So the direction in any object undergoing a circular motion is always changing, but the centripetal force pulls it towards the center so that it can maintain that circular motion, right? So direction is always changing of a body undergoing a circular motion is always changing. Then the velocity is tangential to the circular path. So as this object is moving towards this direction, if it loses the centripetal force, it will fly away with the tangential velocity. So the velocity is tangential, right? The velocity is tangential. Here, as it is moving towards this direction, once it loses that centripetal force that keeps it moving in that circular path, it flies away with that tangential what? Velocity. Right? So this is a very important point that the velocity of an object undergoing a circular motion is tangential to the circular path. Then another important fact that you should know is that the centripetal force and acceleration is directed towards the center of the circle. So the force and the acceleration is directed towards the center of the circle, and that is what keeps the object moving in that circular path, right? So these three important points are very important. They are very important to take note of. So to take us further, let's look at some formula. So this is an object undergoing a circular motion. And like I said, the direction is always what? Changing. You can see the direction that is always changing. The direction is always changing. It's not that it's moving just towards one direction like this. The direction is always changing. And then again, the velocity, which is this v that you're seeing here, it is tangential to the circular path. So if it loses the centripetal force that keeps it moving in that circular path, it flies away with the tangential velocity. It can fly away with its tangential velocity up like that, right? So the velocity is tangential to the circular path. The acceleration, AC, and the FC, which is the centripetal force, is directed towards what? The center. And that is what you are seeing in this arrow. It's directed towards the center. So like I said before, centripetal force Fc is equal to mv squared over r, where your Fc is the centripetal force, your m is the mass, v is the velocity, r is what? The radius. Your centripetal acceleration is equal to v squared over r. This is centripetal acceleration. AC is equal to v squared over r, and it is directed towards the center of the circle. So these two, centripetal force, centripetal acceleration, they are directed towards the center of the circle. Also, your angular velocity, which is represented as this w, is equal to v over r, right? V over r. This is your angular velocity. Then this is the formula for angular velocity. So this is the formula that we mostly use for angular velocity. The angular velocity is simply the rate at which the object rotates or revolves around a fixed point. So you can see this object now moving round. The rate at which it moves round, how fast it moves around, that's what the angular velocity is all about. So from all this, your Fc is equal to your centripetal force. It is the centripetal force, right? Your AC is the centripetal acceleration. Very important. And your W is the angular velocity. So all these are very important. M is your mass, V is your velocity, the linear velocity, not this angular velocity. V is your linear velocity. R is the radius, that is the distance from the center to any part of the circumference, right? That's your radius. And then your V, like I said, is your linear velocity. So these three formulas are very important whenever you're calculating any question on the centripetal force. So let's look at the first question that we have here. An object of mass 4 kg moves in a circle at radius 8 meters at uniform speed of 32 meters per second. Calculate A, the angular velocity, B, the centripetal force. So the first thing that we want to do here is to fish out the parameters that we were given. So let's put our solution here, right? So the question says an object of mass 4 kg. So the mass of the object is equal to what? 4 kg. An object of mass 4 kg moves in a circle at radius 8 meters. So the radius of the circle is 8 meters at a uniform speed of 32 meters per second. So it moves at a uniform speed. Velocity is equal to what? 32 meters per second. Calculate the angular velocity. So we're given mass, we're given the radius, and we're given the velocity. So angular velocity, like we looked at before, so let's calculate our A here. Angular velocity, which is represented as W, is equal to V over R, right? So our V in this question, which is the velocity, is 32. So that will be equal to 32 divided by what? The radius, which is 8, divided by 8. So therefore, our angular velocity will be equal to 32 divided by 8 is equal to 4, right? So what's the unit for angular velocity? It is radian, which is represented as rad per seconds. So this is our answer to this question. So again, angular velocity is equal to V over R. Our velocity is 32 meters per second. Our radius arrow is 8 meters. So 32 divided by 8 will give us 4 radian per second. This is the answer to this question. So let's look at the other question that we have there. We are asked to calculate the centripetal force, right? So let's put the other solution here, B, centripetal force. So what's the formula for centripetal force? Centripetal force Fc is equal to mv squared over r. We looked at it before that the centripetal force Fc is equal to mv squared over r, right? So we have our mass to be 4 kg, right? M is mass. So that would be equal to 4 times our velocity is what? 32 meters per second. So that will be 32 squared, v squared. This is v squared, right? So that will be 32 squared over our radius, which is 8 meters. So this will be equal to 4 times 32. So this is 4 times 32 squared means 32 times 32 over what? Over 8. So 4 times 32 times 32, that will be equal to 4,096. 4,096 divided by 8, right? So that will now be equal to 4,096 divided by 8 will be equal to 500 and what? And 12. And the unit for force, for centripetal force, is Newton, right? So therefore, our centripetal force is equal to 512 what? Newton. This is our answer to this question. Very simple and straightforward, right? So just a quick recap. We've looked at what centripetal force is, and like I said, centripetal force is the force that keeps an object moving in a circular path. There are so many objects that move in a circular path. Your tire, the wheel of your tire, the wheel of a vehicle or the tire moves in a circular path, right? It is the centripetal force that keeps it moving in that circular path. The planets, they are revolving round the sun, right? It is a centripetal force that keeps them moving round that circular path. Even the hand of a clock, the minute hand, the hour hand, and the second hand, they are all moving what? In a circular path. And there is a force that keeps them moving in that circular path, and that is the centripetal force, right? So centripetal force is the force that keeps an object moving in a circular path, and it is always directed towards the center of the circle. It is always directed towards the center of the circle. So if this is a circle and this is an object, let's say this is the object moving in this circular path, the centripetal force is always directed towards the center of the circle, right? So this is the formula for centripetal force. Fc is equal to mv squared all over r, where your F is equal to the centripetal force, your mass, your m is the mass, your v is the velocity, and r is the radius in this formula, right? And then we looked at these three important points: that the direction is always changing, The direction of an object undergoing a circular motion is always changing, and the velocity is tangential to the circular path. And this is what it means, that when the object is moving, the velocity is tangential, right? It's tangential. Once the centripetal force is lost, the velocity will fly up in a tangential direction to the circular path, right? And these are the tangential direction. So the direction is always changing. So if you look at this object, you can see that the direction is always changing. It will go up, turn this way, turn this way, turn this way, turn this way. So the direction is always changing. And then lastly, the centripetal force and the acceleration is directed towards the center of the circle. So the centripetal force and the acceleration is directed towards the center of the circle. So this is very important. And we looked at the various formulas that are important here in this topic. We have centripetal force equal to mv squared over r. Centripetal acceleration is equal to v squared over r, and then the angular velocity is equal to v over r. So these three formulas are very important, right? You have to put them in your head and remember them always. And then we looked at this question, which we solved here. So with this, we come to the end of today's lesson. Thank you very much for listening. See you in our next video.